Hey, welcome to Pomodoro Joe for Sunday, October 8th, 2023. Today we're looking at LeetCode problem 1458, max dot product of two subsequences. This is a hard problem. All right, so we're given two arrays, nums1 and nums2. Return the maximum dot product between non-empty subsequences, nums1 and nums2, of the same length. All right. A subsequence of an array is a new array which is formed from the original array by deleting some or none of the characters, in this case numbers, without disturbing the relative positions of the remaining numbers. So, for example, 2, 3, 5 is a subsequence of 1, 2, 3, 4, 5 because we removed 1 and 4, but we didn't change the order. It's still 2, 3, 5. While 1, 5, 3 is not because they changed the order. All right. So a subsequence is basically just the array that we've removed some or none of the elements, but we can't change the order. So we've just sort of removed them and everything else remains in place. All right, let's see, we have an example here. So our input is 2, 1, -2, 5, and nums2 is 3, 0, and -6. Interesting. So a couple things that are interesting here with this first example. Number one, our two arrays, nums1 and num2, are not the same length. So that means our initial arrays don't have to be the same length. We'll have to remember that. Now the other thing that's interesting is they have negative numbers. Now negative numbers, we might think, oh, we'll just skip the negative numbers and we'll move on. But if you have a negative number times a negative number, you actually get a positive number. So that could be a benefit to keep the negative numbers. All right, and just a quick reminder of what a dot product is. So a dot product, when you have two arrays, it's going to be an element-wise multiplication. So for example, in this case, well, we can't use all of the elements. So let's just take the first three. So element-wise multiplication, and then you sum them together. So this will be element 2 times element 3, so that would be 6. And then element 1 times element 0, that's 0. And then -2 times -6, so that would be 12. So we'd get an 18 if we just did a dot product of these first three elements with these first three elements. Again, that's a multiply of matching elements, and then you sum them all together. Okay, so in our example here, in fact, the best output is 18. So we figured it out. All right, we have some other examples, and I'm not going to bother going through them, but it looks like we have num's length is between 1 and 500, okay? And the numbers themselves can be between 1,000, -1,000 to +1,000. Okay, so we'll put 25 minutes on the Pomodoro timer and we will get started. Now this seems like a difficult variation on your standard subsequence type problem. Now in a standard subsequence, you basically can go through, or my approach is to go through, and you have two options for every element. You just start from the left, you go to the right. For every element, the two options are, do we keep this element as part of our resulting subsequence, or do we throw this element away? So you have two options, keep the element or don't keep the element. And then you recurse, and you go through the rest of the array doing the same thing. Do we keep this element, or do we throw this element away? All right, so in our case, this is a little bit different because now we have two different arrays to go through. And so this sort of doubles our number of options, which isn't that bad. There's still only about 4 options. You can think of this like a truth table where you have true or false. So in this case, when we have two arrays, we can look at the first element of each array and we can keep both of the elements. That's one option. We can throw out element 1 of the first array and throw out element 2 of the second array. So that's 2 options. Or the other way around, we can keep element 2 or element 1 of array 2 and throw out element 1 of array 1. Or we can throw out both of the first elements of nums1 and nums2. Those are our 4 options. So we'll just try them all. We'll go through. Option 1, we'll keep them both. Option 2, we'll throw away one. Option 3, we'll throw away the other. And option 4, we'll throw away both. 4 options. And we'll just keep going until we get to the end, and then we'll return whichever one gives us the best answer. All right, so let's have a recursive function here. So I'll call it max.product recurse. All right, and let's see, we just need to keep track of the index that we're at. So we don't actually need to create new numbers or pass these through. So we'll just keep track of the index. We'll have index 1 and index 2. All right. Now the first thing we always do is create our base cases. So What's the base case? Well, that's if we're out of bounds. So if index 1 is greater than, let's call it max index 1. All right, if we're out of bounds, then we're done and we can return, let's see, what do we return? We could return 0. Let's start with that. We might need to come back and address that later. All right, same thing for index 2. If index 2 is out of bounds, it's greater than max index 2, well then we'll just return 0. Again, we might have to come back to that. All right, now I don't have this max index yet, so let's create those out here. We just need to do this one time, so we'll have max index 1, and that's just the length of nums1. And max index 2 is the length of nums2. So that handles the base cases. Now let's start with our recursive cases. Well, we have 4 options. So option 1. So let's say option 1 is we throw away both of our elements. So the first element of nums1 and the first element of nums2. I shouldn't say first actually. The element at this index. We'll throw away our element from nums1 and we'll throw away the element from nums2. So in that case, we'll just do our recursive call on the next indices of both. Let's see here. So option 1, we're just going to move on, ignore both of these. So this is I1 plus 1, and this is I2 plus 1. Cool, that's an easy one. What about option 2? Very similar, except we're just going to throw away one of the values. So let's see, we'll throw away first one. So I1 plus 1 and I2. All right, so we're just going to throw away our element at index 1, and we'll keep the element at index 2. So that's the element from nums1, and we're going to keep the element from nums2. All right, option 3. Kind of the same thing, except we're going to do the opposite. We'll keep the element in nums1, but we'll throw away the element of nums2, just by advancing to the next index. All right, so these are our options so far. Option 1, we're going to throw away both elements, so we just move on to the next index. Option 2, we're going to throw away the first element, or the nums1 element, and move on. Option 3, we'll keep the elements in nums1, but we'll advance the element of nums2, so we'll throw away that element. All right, and then option 4. This is the trickier one, so we're actually going to keep both of these elements. Now, if we keep both these elements, that means that we're going to multiply them together. So we're actually going to do our multiplication. So we're going to do nums index I1 times nums at index I2. All right, so we're going to keep this, and then we're going to advance to the next 2 elements, which is actually the same thing we're doing here with option 3. So instead of calling this, no, not option 3, option 1. Yeah, so that's the same thing we're doing with option 1. So instead of calling this again, we'll just use option 1 and we'll just add option 1. Cool. All right, and now we have to return which one gives us the best option. So we'll return the max of option 1, option 2, option 3, or option 4. All right, so far so good. And now out here, we do need to kick the whole thing off by saying return max.product recurse, and we'll pass in our initial indices, which will be 0 and 0. All right, so I think this handles everything that we need. Now let's do one thing really quick. We'll actually we'll add a cache. I'm pretty sure this is going to be slow, so let's cache our values along the way. All right, now one thing we didn't address. So this does say return the maximum value. Let's see. Yeah, the maximum dot product between non-empty subsequences. So we cannot have an empty subsequence, which means we could, if we do this ignore all the time, when we get to the end, we'll return zeros. Now it's possible that if we had just negative numbers in one and positive numbers in the other, that we would end up with a negative value, and instead, let's see, how do I put this? If we used none of the values, 0 would actually be better than if we used one negative number and one positive number. So in this case, we're actually returning the wrong thing. A return of 0, we would think that that's a valid answer, but instead we've actually just used up all the elements. We didn't actually use any of our elements, so it is an empty subsequence. And then we return 0, and that's the wrong answer. So instead of doing that, let's use negative infinite here. So this way, pretty much guaranteed that we're going to find something that's better than negative infinite. All right. What else do we need to know? I think that's all we need. All right, let's give this a try and see what happens. Oh, this is nums1, all right. This should be nums1 and nums2. There we go. All right, try that again. All right, our index is out of range. How did that happen? Oh, because my max indices are wrong. These are 0 based, so I do need to subtract 1. Man, so many mistakes. Let's try this again. Negative infinite is not a valid. Okay, so we're returning negative infinite, which is not valid. There's one more option that I didn't consider. Okay, so this option, we're saying, okay, we're going to use both of these numbers, and then we're going to add on whatever we get back from the rest of our array. Well, what if we don't even use the rest of the array? What if this is negative infinite? We get nothing good from the rest of the array. We could just use these two values. That is our subsequence, and then we can move on. So in fact, this option 4 should be, let's do this. Option 4 is that. And then if option 1, let's see, how do we do this? Well, we could do this a couple ways. We could have an option 5. That's one thing we could do. Or we could already do an option 4 here, and we can update it to be a better option 4 if option 1 gives us a better answer. So let's see, if option 1 is greater than 0, then we'll add option 1 to option 4. So our option 4 will plus equals option 1. All right, so that means if we do get something that's a positive value back from option 1, we can actually bump our option 4 up by a little bit. Okay, let's see if that helps. All right, that seems to work. Let's submit this and see if we can pass all the tests. And we pass. Okay, and we don't do great. So we only beat 33% for runtime and only 6% for memory. So this is not the best solution. However, it's clean and it's pretty easy to explain. I think that's why I like this. Now, what could we do differently here? Well, a couple things we could do. Instead of returning negative infinite, we could return none. We could say, oh, we didn't actually get to a value. That's totally acceptable, although I don't think that would speed this up at all. We could do our own dynamic programming instead of using this cache. That might help us. We could do our own max calculation. That would probably help us. Actually, let's jump back and do that really quick. All right. So let's see. This would be, what would be the best way to do this? Let's do this. So we'll call it option A. And option A will be option 1 if option 1 is greater than option 2. Otherwise, we'll take option 2. So this is our own max calculation. All right, and then we'll have option B. And option B will be option 3 if option 3, let's see, is greater than option 4. Else, we'll take option 4. And then finally down here, we'll do our last one. We'll return option A if option A is better than option B, otherwise option B. All right. So it's not as clean as our max call, but sometimes max calls can be expensive. So let's see if this still works. Still works. Let's see if this saves us anything at all. And let's see, a little bit. So we went from 32% or 33%, and now we're up to a 41%. So yeah, it does save us a little bit. Not enough to really make a huge difference. Let's jump in here really quick, see how other people are doing this, see how the best people do this. Oh man, I don't have time to go through all of this. All right, tell you what, you use my code if you need to, but you try this on your own. Jump in, try it out on your own, see if you can solve this problem. Try to do it without using my code first. Then if you need to, you can always come back and watch the video again. And then once you pass, you can jump in here and check out how other people do it and see if you can understand how do they do this. Now, some of these are really nice. Look how clean and compact this is. Now, again, I don't have time to go through this and how it works. So check it out on your own, see if you can pass. If you can, then you can always learn from other people's solutions. All right, well, that's it for me. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.